All right, this is solution to problem 4 from the second quiz. And here we're going to be computing derivatives. And the trick is, because we're taking the derivative of an integral, we want to be using the first fundamental theorem of calculus. All right, so recall the first fundamental theorem of calculus tells us that if we take the derivative of an integral from some starting point to x, and then I have a function, say it was f of t dt, then the first fundamental theorem of calculus says that this is just equal to f of x. So this first problem is exactly in this form. I'm taking a derivative. It goes from here, we start at 0, we go to x, and then my function, right, is sine of the tangent of e to the t. It looks very complicated, and you might be tempted to try to do something crazy in order to try to find an antiderivative for this, but don't. Just use the fundamental theorem of calculus, which tells you that the derivative of this integral will simply be this function f evaluated at x, right, instead of t. So this will be sine of the tangent of e to the x. And that's it. That's how you do problem 4a. Okay, how about b? Well, b has a little bit of a wrinkle to it because it's not going from a constant up to the variable. It's actually starting at a variable. Furthermore, what it's going up to isn't just an x anymore. Now it's a function of x. That's a tip-off. We're going to have to use the chain rule. So the first step, though, is we want to break this up. We're going to break this integral up into two pieces so that we have a constant as one of the bounds. So first we can break it up from x minus 4, well, really up to anything we like. I'm going to put a 0 here. Why not? And then we'll have the cosine of the cube root of t dt. Plus, well, now I have to start at 0 because I ended at 0 here. And I'll go from 0 to x squared plus x plus 1. And again, we have the cosine of the cube root of t. Okay. Now, I want to take the derivative of this sum, which means I'll take the sum of the derivatives. Before I do that, though, I want to make one last modification. Again, we saw with the fundamental theorem of calculus, we want to have our constant as the lower bound. And in this first integral, we have it as the upper bound. But we also know that we can switch the order of the bounds if we include a negative. So I can put here the derivative of negative, and now we'll go from 0 to x minus 4, cosine cube root of t dt. And then the other one I can keep the same. T will go from 0 to x squared plus x plus 1. And again, we're integrating cosine of the cube root of t dt. Okay, so now I want to integrate and then differentiate so I can use the fundamental theorem of calculus. So we'll use f-talk 1. On the first one, the negative will come out. Now I differentiate an integral, and so I'm just going to get my function, which is cosine of the cube root of t, and I get to evaluate it at the variable, which in this case is x minus 4. So I'll have cosine of the cube root of x minus 4. And then I need to use the chain rule and multiply by the derivative of x minus 4. Thankfully, that's just a 1, so that won't change anything. Plus, okay, now the second one, again, I apply the fundamental theorem, and I get to evaluate cosine of the cube root of t at x squared plus x plus 1. But then I need to multiply by the derivative of this upper bound, right? This is a chain rule issue. So the derivative will be 2x plus 1.